Bismillahirrahmanirrahim. Assalamu alaikum. In this lecture, we shall study to find area of a surface of revolution. If we rotate the region about the x-axis, then we have these three cases to find the surface area. The first case is if we are given a function of x, where x is between a and b, and we are rotating the region about the x-axis, then we can use this formula to find the surface area. F of x must be a given function, and differentiating this with respect to x, we can get f dash of x. Case number 2 is if we are given a function of y, and y is between c and d, and we are rotating the region about the same x-axis. In that case, we shall use this formula. Now here, the remaining formula is same, but instead of f of x, we use y here. And we also integrate with respect to y, because the function is given in y. Now, if we are given the parametric equations, where x is equal to x of t and y is equal to y of t, and t is between m and n, and we are rotating about the same x-axis, in that case, we shall use this formula. Now, y of t will be given. We can differentiate y with respect to t and taking its square. Differentiating x with respect to t and taking its square. Now, plugging the values in this formula, we can get the surface area. If we rotate the region about the y-axis, then we have very similar formulas to that of 1, 2, and 3. Look at A. If we are given a function of y, and y is between c and d, and we are rotating the region about the y-axis, in that case, we shall use this formula. Now, f of y must be given, and from f of y, we can get f dash of y by differentiating it with respect to y. Now, if we are given a function of x, x is between a and b, and we are rotating about the y-axis, in that case, we shall use this formula. Now, compare b with 2. In 2, we are rotating about x-axis, so we use y here, and in b, we are rotating about y-axis, so we use x here. Now, the third case of rotation about the y-axis is that we are given parametric equations, but we are rotating about y-axis, so we use this formula. Now, this formula is very similar to that of 3, but in 3 we are rotating about x-axis, so we use y up to here. And in C, we are rotating about y-axis, so we use x up to here. Now, let us solve 6 different examples to use these formulas. In example number 1, we are given a function y is equal to f of x. F of x is x cubed, where x is between 0 to 1, and we need to find the surface area by rotating the region about the x-axis. So we shall use formula number 1. Surface area can be obtained by using this formula, where integration is from a to b, f of x under the root 1 plus f dash of x whole square into dx. Let us say this is 1. Now here we can see that f of x is equal to x cubed. If I differentiate it, I get f dash of x, which is equal to 3x square. And here the value of a, that is 0, and the value of b, that is 1. So using these values in formula number 1, we have s is equal to 2 pi. Integration is from 0 to 1. F of x is x cube, and now we can write 1 plus f dash of x. F dash of x is 3x square whole square into dx. If we further simplify this, we have integration is from 0 to 1, and I can write it like this one. 1 plus 9 x power 4 whole power 1 over 2 into x cube dx. Now here we shall use a rule of integration, which is if we have f power n into f dash, then its integration is f power n plus 1 divided by n plus 1 plus c. Now here we can see that f is 1 plus 9 x power 4, and f dash, if I differentiate it, I get 36 x power 3. So in the above formula, I need to divide and multiply it by 36. So we have s is equal to 2 pi. Let us divide it by 36. And integration is from 0 to 1. Now this is 1 plus 9 x power 4 whole power 1 over 2 into, let us multiply with 36. So we have 36 x cube into dx. Now you can see this is f, this is f dash, and this one is n. So according to the above rule, if I want to integrate, I can get, let us simplify this. From this I get pi by 18. And now the integration is, I'm writing 1 plus 9x power 4 whole to the raise 1 over 2 plus 1 divided by 1 over 2 plus 1. And the limits are from 0 to 1. So now let us further simplify this. I can get s is equal to pi by 18. And now 1 over 2 plus 1, that is 3 by 2. So if I take it up and outside, I can get 2 by 3. And this is now 1 plus 9x power 4. 1 over 2 plus 1 is again 3 by 2. The limits are from 0 to 1. Now let us put the limits. So we have pi divided by, if we simplify this, we get 27. And now let us use the limits. So let us plug in 1. So we have 1 plus 9 into 1 power 4 is 1. So this is 9. 3 by 2. Minus 1 plus 9 into 0 is 0. Whole to raised to the power 3 by 2. Let us simplify this a little more. So we have s is equal to pi by 27. And now this is 10 raised to the power 3 by 2 minus 1. And that is the required surface area. In example number 2, we are given a function of y, where y is between 0 and 2, and we need to find the surface area where the region is rotated about the x-axis. So we shall use the second formula. S is equal to 2 pi. Integration is from c to d, y under the root 1 plus f dash of y whole square into dy. Let us say this is 1. Now for this formula here we have f of y, which is equal to 1 over 3 into y square plus 2 whole power 3 by 2. So let us differentiate this. So we have f dash of y is equal to 1 over 3 into 3 by 2 y square plus 2 whole power 3 by 2 minus 1 into inner differentiation, which is 2y. And now if we further simplify this, we have f dash of y is equal to y square plus 2 whole power 1 over 2 into y. Let us say y is here. Let us put these values in 1. Here C is 0 and D is 2. So 1 implies that S is equal to 2 pi. Integration is from 0 to 2 y under the root 1 plus, and now f dash is y into y square plus 2 whole power 1 over 2 whole square under the root into dy. Let us simplify it. So we have 2 pi, limits of integration are from 0 to 2, y under the root. This is 1 plus. Now here we can write y square, and this one is now y square plus 2, because 1 over 2 will cancel with 1 under the root into dy. This is equal to 2 pi. Integration is from 0 to 2 y under the root 1 plus, this one is now y power 4 plus 2 y square under the root dy. And now from here we have 2 pi 0 to 2 y under the root, and this is now we can write y square plus 1 whole square. We are using formula a plus b whole square, where a plus b whole square is a square plus b square plus 2ab. And now from this we obtain s is equal to 2 pi. Integration is from 0 to 2 y into y square plus 1 into dy. And from this we get 2 pi. Integration is from 0 to 2. This is now y cube plus y into dy. Let us integrate this. So we have 2 pi. Integration is y4 divided by 4 plus y square divided by 2. The limits are from 0 to 2. Now let us put the limit. So we have 2 pi into 2 power 4. This is 16. So 16 by 4 minus 2 square, that is 4. So 4 by 2, and minus, if we put the lower limit, we get 0. From this we have 2 pi, and this is now 4, sorry, this is plus. So 4 plus 2, and if we further simplify this, 4 plus 2 is 6, 6 2s are 12. So we have 12 pi, and that is the required surface area. Let us find the surface area where we are given the parametric curves. And we generate the surface by rotating the region about the x-axis. So we shall use case number 3 here. Surface area S is given by 2 pi. Integration is from m to n y of t under the root x dash of t square plus y dash of t square into dt. Here m is 0 and n is 1. So from x of t we can obtain x dash of t by differentiating it with respect to t. And from y of t we can obtain y dash of t, which is equal to 60. Let us plug in these values in 1. So we have 1 implies s is equal to 2 pi, integration is from 0 to 1. Y of t is 3t square, and now x dash of t, that is 3 minus 3t square whole square plus y dash of t, that is 6t whole square under the root into dt. Let us simplify this. So if we simplify this, we have s is equal to 2 pi. Integration is from 0 to 1, 3t square into 9, 1 plus t square whole square, whole power 1 over 2. That is simple simplification. So students can obtain by simplifying the above equation. And let us write it as 2 pi. Okay, 2 pi, 3 2s are 6. I am writing here 6 pi. Integration is from 0 to 1 t square. And this is now, I can write 3 into 1 plus t square into dt. And if we further simplify this, we have 6 3s are 18 pi. Integration is from 0 to 1. And now we can write t square here plus t power 4 into dt. And now let us integrate this. So we have 18 pi. From this we get t cube divided by 3 plus t5 divided by 5. The limits are from 0 to 1. So just put the limits and simplify this. And we can get 48 divided by 5 pi. That is the required surface area. In this example, we are given a function of y, where y is between 0 and 1, and we are rotating the region about the y-axis. So the surface area can be obtained by using the formula. S is equal to 2 pi. Integration is from c to d f of y under the root 1 plus f dash of y whole square into dy. Let us say this is 1. Here c is 0 and d is 1. Now from here we have f of y, which is equal to 2y minus y square whole power 1 over 2. From this we get f dash of y, which is equal to 1 over 2 into 2y minus y square whole power 1 over 2 minus 1, that is minus 1 over 2. The inner differentiation is 2 minus 2y. And if we further simplify this, we have f dash of y, which is equal to 1 minus y divided by 2y minus y square under the root. And now let us plug these values in 1. So 1 implies that s is equal to 2 pi. Integration is from 0 to 1 f of y, which is 2y minus y square under the root into under the root 1 plus 1 minus y divided by 2y minus y square under the root whole square into dy. Let us simplify this. We have 2 pi, integration is from 0 to 1, 2y minus y square under the root. And from here we get under the root 1 plus, this is 1 minus y whole square divided by 2y minus y square. Root will cancel with square into dy. Let us take the LCM of these two terms and expand 1 minus y whole square. So we get 2 pi, integration is from 0 to 1, 2y minus y square under the root, and from this we obtain 1 over 2y minus y square into dy, which can also be written as 2 pi, limits of integration are from 0 to 1, 2y minus y square under the root into 1 over 2y minus y square under the root into dy. These two terms will cancel and we have 2 pi. Integration is from 0 to 1 of 1 dy. If we integrate, we have y, limits are from 0 to 1. If we use the limits, we have the surface area, which is S is equal to 2 pi. In this example, we are rotating the region about the y-axis. The function is given in x and limits of x are also given. So we use the surface formula. S is equal to 2 pi. Integration is from a to b x under the root 1 plus f dash of x whole square into dx. Let us say this is 1. Here f of x, that is equal to x square, and from this we can get f dash of x, which is equal to 2x. A is 0 and b is 1. Plug these values in 1. We have s is equal to 2 pi. Integration is from 0 to 1 x into 1 plus f dash square. F dash is 2x. So 2x square raised to the power 1 over 2 into dx. If we simplify this, we can write 2 pi. Integration is from 0 to 1. Here we write 1 plus 4 x square raised to the power 1 over 2 into x dx. We use this rule of integration that if we have f power n into f dash dx, this can be integrated as f power n plus 1 divided by n plus 1 plus c. Now here f is given. F is 1 plus 4x square, and if I differentiate it, we get 8x. But here is only x, so we need to multiply and divide it by 8. And we get s is equal to 2 pi. Integration is from 0 to 1 into 1 plus 4x square raised to the power 1 over 2 x dx. So we multiply and divide by 8. Now if we further simplify this, we can now integrate this by using the above rule, which we can write 1 plus 4x square whole power 1 over 2 plus 1 divided by 1 over 2 plus 1. Limits are from 0 to 1. From this we can get pi by 4. 1 over 2 plus 1 is 3 by 2. So we can write here 2 by 3. If it goes up, it will reverse. And from this we can obtain 1 plus 4x raised to the power 3 by 2. Limits are from 0 to 1. Now let us put the limits. Here we get pi divided by 6, and from this we can get, if I put 1, we get 1 plus 4, that is 5. 5 power 3 by 2. If we put 0, we get 1 power 3 by 2. Now if we further simplify this, we have 5 into under root 5 minus 1, and that is the required surface area. In example number 6, we are given the parametric curve and we are rotating the region about the y-axis. So we shall use the last formula given by 1. Students can try to solve this problem. The solution is pi into e square plus 2e minus 6. Let us see the summary. If we are rotating the region about the x-axis, then in all formulas there is y. You can see it. However, in the first case, we use y is equal to f of x because the whole data is given in x. Similarly, if we are rotating the region about the y-axis, then in all formulas there is x. However, in the first case, we replace x by f of y because x is f of y, and all the data here is given in y.